Algorithm DAA Crash Course plus Previous Year Solved Papers. I am Dr. Durgesh Kumar, currently working as an assistant professor in the Department of Computer Science at VIT Vellore. So why you need to see this playlist or how this playlist will help you in your academic journey. The focus of this playlist is to engineer your marks while optimizing your effort. So the core approach of this playlist will be a algorithmic mindset for the exam success. So the problem statement here is you want to maximize your exam marks while you have limited hour of study. So the solution is not to read more like a brute force approach, but to think right. So in your optimal exam preparation for the maximal marks, you have to have a right concept, consistent practice, and a optimal effort. So through this lecture series, I will help you to go through these three components to maximize and engineer your marks. So this process will return you the maximum marks while maintaining the constraint of the limited hours of study, but the fundamental approach of the correct concept, consistent practice, and optimal effort. So this is the highlight of the playlist. So the lecture format will follow in this following way. We'll have a first lecture of where we will quickly describe the problem and its constraint, followed by the how to solve this problem using a particular algorithm design pattern or paradigm, like say brute force, say divide and conquer, say dynamic programming. We'll quickly analyze the time and space complexity of that particular algorithm. We'll see one representative problem and an overview of a solution, not a detailed solution. So this should take the 15 to 20 minutes of your time, where we will have just a problem definition, the quick overview of the algorithmic solution and the intuition, time and space complexity analysis, and one representative problem so that we understand the problem well. And this representative problem will directly from the some university or the college previous year question paper. In the following two or three video, we'll discuss two or three previous year university or the college paper on the same topic, same algorithm with a step-by-step detailed discussion. This will help you not only to understand the algorithm in the clear, concise, and right way, but to maximize your marks because you will understand what the examiner is going to expect in that particular problem. As a part of this lecture series, we will study the divide and conquer approach, greedy algorithm design pattern, dynamic programming approach, backtracking, and branch and bound. Ideally, I expect 1 to 2 week for this crash course plus revision for your university or the college exam. In the first week, you should be able to cover this four pattern, divide and conquer, greedy algorithm, dynamic programming, and backtracking. We'll also look into the major problem domain category, such as the string algorithm. Given to string, what is the minimal or the maximum overlapping string? Given a graph, how to find the shortest distance between all pair of vertices, fixed source, or how to find the minimum spanning tree, or how to find the maximum network flow that can flow between any two edges in a graph. We'll also study the geometric class of algorithm where given a two line segment or two planes, how to find their intersection. Then we'll study the optimization problem. Given any problem and the constraint, how to maximize or minimize the goal. This kind of problem will often occur at multiple places. Say the maximum subarray problem will also fall under the optimization problem. Given an array, find the subarray that maximize the sum of its element. At last, we'll discuss the other aspect of the algorithm problem that are important from the algorithm design perspective and the algorithm expert. You should be able to derive time and space complexity in terms of big O notation, omega notation, theta notation. These are called asymptotic bounds, asymptotic analysis of the algorithm. So time and space complexity will go through for each of the algorithm. We'll also discuss the brief correctness proof, the intuition, what are the key steps, so that given a algorithm, you propose a new algorithm, how do you convince the complete algorithmic society that the algorithm given by you is correct and will work for all the exhaustive test cases, not for just a single or a some test cases. So there is a particular way to show the correctness proof of the algorithm. Then we'll discuss the different class of algorithm P, NP, NP hard, NP complete. This class of algorithm is designed to let you know which particular problem or the class of a problem is relatively harder than the other class of a problem, and can we ever achieve a polynomial time, ideal polynomial time algorithm for a particular class of a problem. Furthermore, if we have a polynomial time solution for a particular class of problem, can you utilize this particular solution to have the polynomial time solution of other class of a problem? So this all we are going to study in the third part, P, NP, NP hard, NP complete classes. So we'll start with the algorithm design pattern one by one. In Divide and Conquer, we'll discuss the maximum subarray and the Karasuba fast integer multiplication as a part of our first week. However, you might have studied the merge sort, quick sort, binary search in as a part of your data structure algorithm or other programming courses. I would highly recommend you to go through the stress and metric multiplication code or the algorithm for your competitive exams or the placement exams. However, keeping the time in the constraint, we'll discuss the maximum sub array and the Karasuba fast integer multiplication only for your college syllabus. In the greedy algorithm design process, we'll discuss the Huffman encoding and the fractional knapsack. You might have already seen the Dijkstra algorithm single source shortest path and the minimum spanning tree Prince and Kruskal algorithm that also falls under the greedy algorithm design technique. You can explore on your own for the activity selection problem and the job sequencing problem with the deadlines. Proceeding forward, the most important algorithm design technique, the dynamic programming, which will often come in your college syllabus as well as your competitive coding, will discuss the five important types of problem which can be mapped to the most of the problem that you see. We'll start with the 0 1 knapsack problem and the LCS problem. This LCS and minimum edit distance are all closely related and can be easily transformed into one another. And these two problems are often asked in the internship or the placement exam for Microsoft or a Google at the college level, and it is very easy to understand and solve it in the limited time. We'll move towards the matrix chain multiplication. Given a sequence of matrix, what is the ideal sequence or the order for multiplying the matrix so that we will have the minimum number of scalar multiplication? Then we'll study the traveling salesman problem using the dynamic program. At last, we'll discuss the backtracking design technique where we'll study the NQueen problem, subset sum, and the graph coloring problem. And this all three we are going to cover in the week one itself. Why you should see this playlist, what you can expect from this playlist. So this playlist is meant to design and engineer your marks with the optimal effort, the correct concept, and consistent practice. So these three keywords will do the magic so that you can engineer your optimal mark. Why this is important? Because this will act as a gold standard and exam focus for the preparation of the college exam in the limited time. It will cover the high frequency previously asked question paper on a certain topic. So if you practice those questions, you are ready for your subjective exams. We'll also briefly discuss how the questions are designed, what are the intuitions or the question paper setter's mind, what goes inside the question paper setter's mind, what are each constraint, how does a question paper frame a question. Then we'll also discuss the evaluator mindset. How does a faculty who is evaluating your paper award the marks for your a particular questions? What are his constraints? What he is looking for the keywords or the steps in your answers. So we'll understand the step-by-step problem solving mindset so that you optimize your marks. So we'll discuss the correct approach and divide the complex solution into the step-by-step process that will lead you to the high scoring marks with the optimal effort. In the next lecture, we'll discuss the divide and conquer approach using the maximum sub-array problem. So I hope you are clear the scope of this playlist, how this playlist can help you, and what to expect from this playlist. So, ideally, this playlist will help you to prepare for a college level algorithm exam within 1 to 2 weeks, given that you have a rough idea, brief idea of the algorithm from your classroom. You partially know about the algorithm, you have partial idea about their approach, but you don't know what to write, how to write. So we will this can be discussed in this lecture series, and you will be able to score high marks. So I would highly appreciate your feedback and suggestions in the comment sections. Please feel free to write your comments, suggestions, or any doubts that you faces while studying this playlist or any algorithm questions. Thank you, everyone. If you have any questions, I would love to answer your query and help you in your preparation journey. I will also share the contents that is used in this lectures series in the Google Drive in the pinned comment or the descriptions. I will also have a separate playlist where I am going to discuss this topic in more detail, like a classroom lectures version. Thank you, everyone. Thank you for your patience. I'm looking forward to complete this series with you and help you in the maximize and your algorithm journey and love the DA subjects. See you all in the coming lectures. Okay, so please feel free to share this with your peers so that more people can utilize this opportunity. Thank you, everyone.